In this video, I'm going to instruct you on how to create a stem and leaf plot. Okay, given a set of data, the first thing you're going to want to do is put your data in order from smallest to largest. In the blue numbers across, I've already done that for our first example. A way you might do that is load those into your calculator, into L1, and do a sort ascending. And then your data is nice and pretty in order, and it's not real difficult to handle that. Okay, so we're going to create what we call stems and leaves. So when you go through and do a stem and leaf plot, I'll just do kind of a sidebar over here. A stem and a leaf. Let's say I have the number 14. Okay, so we're going to split that so that your leaf part is a single digit. Okay, and your stem is the first. So that's read as 14. Okay, let's try another one. Let's say like 127. I'm just kind of doing a sidebar over here. So the stem part on this one would be the 12. The leaf part would be the 7. 127 would look like that. 105, like 105, would be 1, 0, and then a 5. But the leaf part always is a single digit. Okay, so that, like I said, just a little stem or sample off to the side. Okay, so let's do an example here. I have this set of data. I put it in order according to the blue numbers. So we are going to create a stem and then a leaf plot. Okay, this part over here, if you want me to call it, some books will say this, like a trailing digit. Okay, the stem part could be the leading digit. Okay, just some different vocab you might see if you were reading this or seeing another example somewhere. Okay, so the smallest number we have here is a 2, and I made a drama out of it and put it as 0, 2, just to point out that the stem for a single digit is going to be 0, the leaf part's 2. Okay. Next up is 13 and 14. 13, 14. So that means the stem is 1. We have a 3. So that's 13. And then you're going to put a 4 right beside it. You do not separate with columns. You just, you just write it next to it. Okay. Next set of stems are in the 20. So with a stem is going to be a 2. We have a 20, 23, 25. So it's a 2, 0, a 3, and then a 5. Okay. Next stem is 30s. Okay, we have several of those, so we'll just go across here. So 31, so it's a 1. 32, 2, 3, 4. So 1, 2, 3, 4 2s. 36, or sorry, 33, and then there's a 36. Guess I'm up to here. 33, 36. Okay, next stem's the 40s, so 4. We have 43, so 43. 44, 44, 45. And the last stem, we're in the 50s over here. So 51, 52, 57. Okay, so that is your stem and leaf plot. If you were to kind of turn your head sideways and look at this, like we've talked about histograms previously, okay, like so, maybe you can see your histogram coming across here. And if I were to ask you the shape, looks to me like this is symmetric, or I know some of us are into saying bell-shaped at this point, so we could say bell-shaped curve. Okay, and that's nice. It would show you that. Okay, all right. The next example I have, I might want you to pause the video right now, and you could put your Atlanta data into L1, the Philadelphia data into L2, and I would have you sort these numbers. Okay, so sort the numbers, both data sets. Okay, so sort L2, sort L1, and we're going to create what's called a back-to-back stem and leaf plot. Okay, so if you want to go ahead and pause the video, I would wait, but I can't tell what you're doing. So, okay, all right, so to do a back-to-back stem and leaf plot, we're going to have one set of information, Atlanta, on one side. we're going to put a stem in the middle, and then we're going to have the other data come out the other side. Probably the most important thing about a back-to-back stem and leaf plot is that everything goes in order from the middle, so from the stem. Right, so for example, if you have your Atlanta data sorted and you happen to put it into L1, you'll see that your first stem is a 2. And you should see like, oops, there, sorry, 20, whoops. Hold on here, let me get that out of here because that looks kind of a mess. Let's try again. Okay, so first stem, you're going to be in the 20s. Like I have 26, 28, 29 are the first numbers for Atlanta. So from the stem, I'm going to go in order. 6 for 26, 8 over here for 28, and then 29. Okay. Next stem you're going to see for Atlanta is in the 30s. Okay, so I have, let's see here, 31. 1, 2, 3. I have 5 2s, 2 4s, a 6, and an 8. So a lot of things in the 30s. Okay. Next stem for Atlanta, I have 40, 40, 44, 44, 47. I have some 50s, so let's see here. I have 50 and 50, 52, 52, 3, 5. So again, I'm just putting the stem in the middle for 50s and then those secondary trailing digits beside it. Okay, 60s, so I have a 60 itself and then a 63, so 63. And then the last one I show on my list is a 70. Okay, so then if you take your calculator and you're going to switch lists now, okay, so switch, go back to Stat Edit, go to L2, and if you have it sorted for Philadelphia's data, I'm starting with a 25 as my smallest number. So beside the 2 stem, I'm going to put 25. In the 30s, there's 4 30s, so 4 30s, couple 32s, 33, a 34, there's 3 36s, 2 38s, 2 39s, so there's a lot again in the 3. Next is 4 40s, so I'm going to put 4 zeros for those, 40, 40, 40, 40, 50, so 50, 53, 54, 58, so 50, 53, 54, 58 for those numbers. There's a 61, and then that's it. There's nothing in the 70s for Philadelphia. Okay, so again, this is a back-to-back stem and leaf plot. Everything is in order from the stem. Okay, and you could compare them side by side. Like you might ask, what is the most popular number of stories in the tall buildings in Philadelphia and Atlanta? Well, I would say it's in the 30s. 30 stories seems to be the popular, okay, because both of those have a max value there. Trying to think something else I might mention. The other thing, occasionally, you might see something called, I think it'll fit on here, a split, oops, let me try that again. I wasn't sure, let me fill in down here. But it's called a split stem and leaf plot. Okay, so for example, I don't know, let's take that Philadelphia data. Okay, and if I want to do a split stem, I start this stem and leaf just like before. Okay, so I start with a 2. So I would put 2 2s, 2 3s, 2 4s, 2 5s, 2 6s, and 2 7s. Okay, so the idea of the split stem is, in the first category will be anything from 0 to 4, so from 20 to 24. In the second category, we'll go anything from 5 to 9. So that's the idea of the split. And to kind of think of it like rounding, 0 to 4 and then 5 to 9. All right, so in our Philadelphia one, we start with 25. So I'm looking up here at the top. Okay, so 25. So we have nothing here, and then we'll have a 5. Okay, when you come down to the 30s, okay, you're going to go all the way across there until you get to the 4, and then you split it. So we would, in the first row for 3s, put 4 zeros, 2 2s, a 3, and a 4. Then the rest of it goes in the secondary part. So the 6s, the 8s, and the 9s. So again, between 0 and 4, and then 5 to 9. Okay? In the 4s or 40s, we have 4 zeros, and then nothing. In the 5s for Philadelphia, okay, so I'm looking in here. So I have a 0, a 3, and a 4, and then an 8. So it's going to split right here. And then 61, and then that's all I have. Now, I cannot just erase these extra stems. They have to stay. We have to stay and be in consecutive order. Okay, now, why would you want to do that? It gives you more details. Okay, and sometimes that can be helpful in describing shape. It can also help us to look for outliers. Okay, so it just, the details, the shape, that's why you might want to do this thing called a split stem. Okay, and I started to mention this over here about once you start with a split, you're not allowed to skip anything. Back up here at the very beginning of our notes, I made a mention to right here. If there are no data values in a class, you should write the stem number and leave the leaf number blank. You may not skip, okay? So just something to keep in mind as you go through that, okay? So again, this sort of diagram is a stem and leaf plot. It's very useful to determine shape, outliers, distribution of the data. I like it a lot because you're actually using the physical numbers to create the graph, and they're always there so you can see things. In a future lesson, we might even look at this and talk about things such as the mean, the median, mode for back-to-back and that sort of thing. And again, it's because the data is right there. Okay, enough for me. Gonna sign out now. I've got some pork ribs on the smoker and some meatloaf wrapped in bacon. I better go check it out. Hope you all have a great day, and thanks for watching.